Today we are talking about 1.9a inverse functions. A little bit of a review for inverse functions. Let's say we were given a function f of x equals, let's say the square root of x plus 2. To find the inverse function of that, what you would do is you would switch your y and your x to find the inverse function. So if I were to switch our y and our x would be x equals the square root of y plus 2. So then we need to square both sides, squared. And then you're left with y plus 2, subtract 2, x squared minus 2 equals y. So this is our inverse function of f of x equals x plus the square root of x plus 2. So I'm going to write that as g of x. Say g of x is then x squared minus 2. Now let's say, so we know this is for sure the inverse function, but how can we also check algebraically that these are inverse functions? Well, to check it algebraically is the rule of inverse functions is that they are symmetrical. They are symmetrical over the function y equals x. So that means if I were to put one equation into the other, it should result in just a plain old x. So if I took f of g, then let's say here, then that's x squared minus 2 plus 2. This is x squared. And then this is just plain old x. So that works. What about g of f? G of f says the square root of x plus 2 squared minus 2. Well, that squared makes it x plus 2 minus 2. That is also x. So algebraically, it works. Now let's think about this in terms of a graph. What if we have to show this graphically? Well, first things first, let's go down here. Let me rewrite our equations just to remind us a little bit. F of x being the square root of x plus 2 and g of x equals x squared minus 2. If I were, remember, it has to be the same from one side or the other from the line y equals x. So this dotted line here, it should be symmetrical or the same, kind of mirror each other from one side to the other. So let's draw f of x first. I'll draw that in green. Say f of x equals the square root of x plus 2. The square root of x plus 2, luckily here, kind of looks like a, sideways parabola. But however, since it is plus 2, that means we will be moving to the left 2. So we'll go over to the left 2, and it should look like a sideways parabola in a bit here. And then g of x equals x squared minus 2. I'm going to draw that in red. G of x. Well, this is a regular parabola, but it goes down to, so it starts down to here, and it's just a plain old regular parabola like so. So it goes up 1, and then the next one should be 2, the next one should be 3, and so on. And as you can see, the two equations are symmetric over that line, and that is basically all of 1.9a.